Assalamu alaikum, welcome back to Modern Study Pro.
Today, we are going to pull back the curtain on a hidden science that honestly powers almost everything in our modern world. I'm talking about the phone in your hand, the future of cars, all of it. This is electrochemistry.
So, let me ask you a question. It sounds a little bit like a riddle, right? What could your phone battery, a rusty old nail, and a super high-tech hydrogen rocket possibly have in common? I mean, they seem totally unrelated, but they're all connected by the exact same fundamental science.
And the answer, the thing that ties them all together, is electrochemistry. It's this incredible, invisible dance between chemicals and electricity. When you boil it all down, the definition is actually pretty simple. Electrochemistry is all about chemical reactions that either create electricity, think of a battery draining, or reactions that are kicked into gear by electricity, like charging that same battery back up. The best way to think about it is like a two-way street for energy. In one direction, you have chemicals that just naturally want to react, and in the process, they spit out electricity. And in the other direction, we can pump electricity into a system to force a chemical reaction to happen that wouldn't normally occur on its own.
Now, to really get a handle on this, chemists have a kind of weird little phrase they use. An aux, red cat. It sounds strange, I know, but trust me, it's a super useful mnemonic that helps you remember the two halves of every single one of these reactions.
See, an aux reminds us that oxidation happens at the anode, and oxidation is just the loss of electrons. Then, red cat tells us that reduction happens at the cathode, which is the gain of electrons. And this electron swap, called a redox reaction, is the engine driving all of electrochemistry.
So, if we go back to our two-way street analogy, you'll find there are two main families of electrochemical cells, and each one basically directs traffic in one of the two directions.
So on one side, you've got electrolytic cells. These are the ones that use up electricity to create a chemical change. Think about charging your phone. You're putting electrical energy in. On the other side, you have galvanic cells. They do the complete opposite. A chemical reaction happens all by itself inside them, and it produces electricity. That's your phone running when it's unplugged.
All right, let's explore that first side of the street, the one where we're putting electricity in. This is the world of electrolytic cells, the workhorses that use power to make things happen.
You know, a perfect example of this that you see all the time is electroplating. It's a huge industrial process where we use a controlled electric current to put a super thin, perfect layer of one metal onto another.
And the way it works is actually pretty cool. You take the thing you want to coat, say a cheap fork, and you make it the cathode, the negative end. The metal you want to coat it with, maybe silver, becomes the anode, the positive end. You dunk them both in a special solution, and when you turn on the power, that electricity literally forces silver ions to travel across and build up on the fork, giving it a beautiful, even coating.
So, why do we do this? Well, it's incredibly useful. We put a layer of zinc on steel to make galvanized steel that doesn't rust. We coat the inside of food cans with tin because it's non-toxic and protects the food. And of course, we put chromium on car parts to get that brilliant, durable shine. It's all about protection and making things better.
Okay, now let's cross over to the other side of our energy street. Here, we're not putting electricity in, we're getting it out. Welcome to the world of galvanic cells.
This is going to sound simple, but it's huge. Every single time you use a battery, any battery at all, what you're really holding is a self-contained portable galvanic cell. There's a chemical reaction happening inside just waiting to release its energy as electricity. And that's really all a battery is. It's just one or more of these galvanic cells cleverly packaged together. They're specifically designed to take the energy from that chemical reaction and release it as a nice, steady flow of electrons, which we call an electric current.
Now, this basic principle, creating electricity from chemical reactions, is leading us towards something that could be a massive game changer for our energy future, the fuel cell. It's a very special kind of galvanic cell.
The hydrogen fuel cell is just so elegant. You feed it hydrogen gas as the fuel, and it grabs oxygen right out of the air. Inside, an electrochemical reaction combines them. And you know what comes out the other end? Just two things, electricity and pure, clean water. That's it. No CO2, no pollution, nothing.
And here's the kicker. It's not just clean, it is incredibly efficient. A typical hydrogen fuel cell can turn about 70% of the energy stored in its fuel directly into usable electricity.
Now, to really understand how amazing that number is, just look at this comparison. The regular old gasoline engine in your car, it's only about 25% efficient. That means most of the energy in the gas is just wasted as heat. The fuel cell is almost 3 times better at turning fuel into power. I mean, when you put it side by side, the bottom line is pretty stark. You've got fuel cells with super high efficiency and zero pollution compared to gasoline engines with low efficiency and high pollution. The advantage just seems obvious.
So, you have to ask, right? Why aren't we all driving hydrogen cars? Well, this is where the big real-world challenges pop up. For one, hydrogen gas is super flammable, and it's really hard to store safely and compactly. Making the hydrogen in the first place is also expensive, and right now, a lot of it is actually made using fossil fuels, which kind of defeats the purpose. And finally, you can't just pull into any gas station to fill up. The infrastructure just isn't there.
Which leaves us with this huge, critical question. We have this technology that can make completely clean power from hydrogen, which happens to be the most common element in the entire universe. The science works, but it's the engineering, the economics, and the infrastructure problems that are standing between this incredible scientific promise and our everyday reality.